In this lesson, we are going to look at Resource Monitor, a very similar tool as TCP View and Netstat. Let's get into it. To start the Resource Monitor, what we can do is we can go to Start, type Resource Monitor. So the icon looks something like this. Click on Resource Monitor. It is very similar to Task Manager or Process Explorer or any such tools. It displays pretty much the counters of the system. You have CPU, memory, disk, and finally network here. There is a network in the overview. That is not exactly what we are looking. In fact, this network tab right here is a superset of the overview. So we will be focusing on network tab of the Resource Monitor. So as I mentioned, it has pretty much similar information as TCP View as well as Netstat command. So in this case, we can see different processes or applications. So these are different applications, just like our Python application, which has connected to internet and sending this much data. For example, traceagent.exe. I don't know what it is. I can look up. So it is sending this much data at the moment to the network and receiving this much data. So this is almost real-time network traffic right now happening in this system while we are talking. Then there is this process agent. Again, I have no idea what it is. So if you want to know more information about this, we can look at the task manager. So if you go here, go for agent, looks like something like Datadog. If you want to know, go to service. So there is a Datadog agent service. Pretty much Datadog is stealing some data from my laptop, which they always do. If you want to know what it is taking, we will see shortly. But I am giving you an overview how the UI of Resource Monitor is looking. So sending this much data, receiving total this, and the process ID. We have seen similar information in TCP View. So that is process with network activity. Again, this is Windows specific. In Linux, I'm pretty sure there are tools like this which does exactly similar things. Network activity, pretty much similar information. It's just that it gives you the address as well. Probably you can add more columns here, remove certain columns, all that kind of things. Typical Windows stuff is there. Nothing hugely different from process with network activity and network activity. But as you can see here in this small list, we don't have our Python. Why is that? Our Python is still running. So let's have a look at the status of our server and client. So the client is about to send information, so it is still not executed, line number 9. How about server? Server is still listening or expecting data, waiting on this particular line. But we don't have anything in here. So as you can see, this particular list here is very dynamic. Things goes out as well as come. So this is very dynamic. So the Python was not there before, but it came up. In fact, I don't think it is the Python we are looking for because our Python is not actively transferring any data. So those two Python has gone, some other Python has came up. So this is very dynamic, real-time information. Our process, our application, our code, our server and client we have developed is broken into the debugger, and it is not sending any active packets, active data to the network. That's why it's not coming here. In future, we will modify our code in such a way that it will come here. We'll continuously shuffle data between client and server such that it'll come here. But till then, we'll look at other stuff. So network activity, as I mentioned, similar to process with network activity. Now TCP connections. Let's see what it is. So we have image right here, then the process identifier, local address, local port, remote address, remote port, packet loss latency. So these are the things which is there in TCP connections. So if you go to select columns, we have some more options here: send, and receive and total. So this is again same as on the top. Now these are active connections. Now let's see Python here. We are expecting our Python to be present here because we have a connection. We have an entry inside TCP view and netstat. Those entries we are supposed to find it here. Now what we are going to search? We are going to search for our port number just like we did before. So I sorted it with port number. So this is the port number right here. We don't have any send bytes or receive bytes, as you can see here. And our port numbers remain the same. So this is our local port and this is our server 20260. That's our server 65432. To verify all these things, what I'm going to do is I'm going to launch TCP view just to make sure that we are seeing exactly same thing in both tools. So this is our TCP view. I'm going to start it again. You need to run it as administrator. So this is our TCP view. In this case, what I'm going to do is I'm going to put a filter. I don't want so many things here. So what I'm going to do is I'm going to put a filter. Filter is again our port number 65432. So remember, this is the filtered output, not the full output. The full output is the one before. So filters can be a little confusing. So make sure that when you look at this, there is nothing here. If you mess up one number here, you will not get any output. So I don't recommend using filters if you're a beginner, but in this case, we are going with a filter. So we have put a filter on our server port. So that is what it is displayed here. Let's see that information in resource monitor as well. So back to resource monitor, I'm sorting it with a local port. I have one of those entries right here, 20260. That is the number we are looking here. Coming to TCP view, 20260. The status is established and local address, remote port, local port. So it is matching exactly as it is in the TCP view. Now, how about this entry? For that entry, I'm going to sort it with remote port. Again, we got it right here. The Python is the client in this case, 13976. That is the process ID of the client. That is a client application. So it is right here, the client 13976. Exact same local port and a remote port. In the case of client, the local port is 500.16. Now, listening stuffs, we don't have this thing here. That thing in resource monitor is right here, listening port. So listening port doesn't have a remote entity, it's just port. There's no a remote listening port. Listening port is always local. And the number we are looking here is pretty straightforward. It is our golden number 65432 and it is right here, and this is our server process 20260. Now if we restart our client and server, all this will change except this one number. Let's see what are the numbers which is going to change if you restart everything. So the process IDs will change if you restart our application. For example, if you are doing it yourself in your local machine, these numbers will change. This will stay exactly as it is because this is coming from our code. This will stay exactly as it is. Sometimes in some tools, you will see your host name instead of remote address, but that's okay. We have discussed it's the same thing, but otherwise this is gonna stay same. This number 500.16 will be random. We'll discuss all these things in detail. Client socket. Client socket is a random thing, especially in the sense of the client port. A socket needs a combination of IP address and port, and this will be randomly chosen for the client connection. So that is all I wanted to show you in a resource monitor. We have nice little graph here. Feel free to play around it, but ultimately it is the same information we have seen in other tools. These are the different options for the listening ports. One good thing with Resource Monitor is, if you're on Windows, of course, is that it is by default coming with the operating system and very user-friendly and easy to look at. So I always use Resource Monitor when it comes to troubleshooting network problems in Windows. So that is all about Resource Monitor. Let's get to our next tool. To conclude, we have seen Resource Monitor in Windows, very similar to TCP View and Netstat. We have not found so much new information in Resource Monitor. It was exactly the same kind of information we found in Netstat and TCP View. One thing I would like to highlight here is that Resource Monitor is not to be confused with Network Monitor or Netmon. There was a tool in Windows which is obsolete right now called Network Monitor. That tool is similar to Wireshark, but it is obsolete now and I don't think it is available at all. So we will be using Wireshark in favor of Wireshark versus Network Monitor. But what we have seen is a Resource Monitor. So the name looks similar, that's why I'm putting it here. Now let's look at a different tool called Process Explorer to dig further into the mystery of these programs we are looking at.